So this is today's session. If you're in the wrong session, please stand up and go away.
This is a secret session. The Channel 9 app doesn't list it. It does now.
Yes,
At noon, I'm like, wait a minute.
yes, this session was embargoed until today, until we did the announcement this morning. Cool. So my name is Nicola. I'm a program manager with the evangelism team within Microsoft. I've been working with the Xbox team very closely for the past year, working on the Xbox app development. I've been also had the opportunity to work with Windows 8 applications and Windows Phone applications. So I thought, well, why not just combine all of them and just write for all of them instead of writing for just one? So basically today is just to talk about how to share the code as much as you can between all of these applications and minimize the amount of effort when you write for all three platforms. Now, before we get into the session, I want to use this slide. We're on the path to Windows Phone, and Xbox convergence. And we had a little, Terry Myerson this morning had in the keynote, he presented the Khan Academy, which was running in a project that had all three projects, the same solution. And we saw that application running on Windows Phone, and Xbox One. Now, we haven't announced yet when you're going to be able to do that same thing. And if you have any questions, we're going to do that at the end of the session. But the goal of this session is to teach you how you're going to take the same code and how you're going to start writing your projects on Windows and Windows Phone today so you can take the exact same code and put it on Xbox. The platform for Xbox is still is getting closer and closer to Windows and Windows Phone. It's still not as close as Windows and Windows Phone are. So we're working very closely with all the teams within Microsoft to make sure all the platforms converge to as much as possible. But we're not there yet. So the agenda for today is we're going to go through some comparisons about all three platforms. We're going to talk about what are the similarities and what are the differences between them, just to go over just so you can know exactly what you can share and what you cannot share, so you know exactly, before you get started with writing your code, you need to know exactly where you're getting into. And then we're going to talk about some of the patterns and some of the things that I found helpful when writing for all three platforms. Some things I've learned the hard way, some things I've known before, so I've tried to include as many things as I could about helping you write for all three platforms. We're going to touch a bit on C++ and how to also use C++ to write code for all three platforms. And then we're going to see a bit more about the Khan Academy that Terry showed this morning. So starting with the comparisons of all three platforms, first things is that all three platforms run on the same core, the same Windows core, and they share the same runtime APIs. Not everything is shared naturally because these are still three different platforms, but being based on the same core allows them to share as much as the code as possible. So these are some of the APIs, not all of them, but some of the APIs that are shared, and there's a lot more that are shared, but these are some of the APIs that are most popular with developers. Of course, there's a question? There are some features that are not available on all the platforms, and that's, of course, there are different platforms, so there's different user experience or different features. So you need to know what are the differences between the platforms, so you know what are you going to develop on one, what are you going to develop on the other one, and which part you can share. So we actually have a session tomorrow by Rob Cameron, who's here in the room, who's going to be going a bit more deeper into some of these features and have some examples for you. So one of the biggest differences between the platforms is going to be the form factors. Naturally, these are, again, three different hardware devices. The operating systems run three different hardware devices. So you have the phone, of course, which is a small handheld device, usually portrait, small resolution. You can't put as much information on the phone. And then you go to the Windows, which it has more real estate, high resolution, can go on screens from tablets to desktops to even presentation TVs. So it has different uses, and you can use it mostly with mouse and keyboard. And then you go into the Xbox. And this is usually used for media applications. I mean, of course, there are different uses, but before in the past, it's been used mostly for media. And people tend to use it from a little far away, for about 10 feet experience. And they don't have the same input modalities as they have on the Windows and the phone. So these are all three different form factors. So when you develop your applications, you have to keep in mind that you're not writing in one application. We're not writing an application. The same application will run all three platforms. You're running an application. You're writing three applications that have shared code. So the goal of this session is to maximize that, how much of that code you can share, because you still have to account for the different experiences. Of course, one of the biggest differences is going to be the input modalities. Xbox uses the Kinect and the controller for most of the navigation throughout the applications. You use gesture and voice, which is not available on phone or Windows. We are bringing Kinect for Windows, and we're going to have a session on that later today by Chris White, so you can watch that session. But as it is today, the keyboard, touch, and mouse is only for Windows, and controller, gesture, and voice is for Kinect. So you need to make sure that you design a native user experience for each platform. Do not try to write the same application for each platform, because the user experience will not be right, and your users will not want to use your applications. And we actually have a session on how to write applications for the 10-foot experience by Eddie Mays, which you should all definitely go and see. So as from the title of my presentations, we're going to use HTML and JavaScript for the development of the applications on all three platforms. And then we also have C++ CX available, which allows us to use any existing libraries with decades of community experience they can take advantage of. So naturally, with JavaScript, there's a lot of community frameworks you can take advantage of when you're writing your applications. WinJS is available on all three platforms, but it is not required. So you can write entire applications without using WinJS. All runtime APIs, all the Windows runtime APIs, Kinect is all available directly through JavaScript. And you do need to write support for all input modalities. So it's something you have to keep in mind of when you're writing your applications. It's something that WinJS helps with, but again, as it's not required, it's something you need to think about. So just a little example on how to add Kinect support in your applications. So before on, sorry. So WinJS the WinJS controls already support voice and gesture natively. But if you're not using WinJS, then there's very easy to add voice and gesture on your own applications directly. So this is, for example, a code snippet that adds voice in your custom controls. So for example, if you want to have a diff that can be invoked by a voice command, you simply add a custom attribute called data_when_voice to your code. And you specify what you want the handler for this to be, or if you don't specify handler, the click handler will be called. What do you want the command to be? So you can say anything, or you can even specify an element within this element that contains the command that you want the Kinect to recognize. I'm not going to go into much detail. We actually have another session by Gersh, who's going to be going a little bit more into detail about how this works and also some of the controls in WinJS. But my point here is you can put this in your HTML code, and since it's a custom attribute, it's not going to break your Windows or phone applications. So this is code that you can still share between your applications. You don't have to write different HTML for different, if you only just because you've added voice to your application. So it's not going to break your application. And then for gesture, it's even easier, because Kinect gestures is basically enabled via the same touch intervention engine as Windows. So you get the same pointer events that you get with touch or a mouse or a pointer. It's very natural. In fact, applications that rely heavily on touch for Windows work with almost no effort on Xbox just by using the Kinect. Now, of course, WinJS is available on all three platforms, and that's something that you can take advantage of to help you share your code across applications. And it comes with many utilities that exist on all three applications. Of course, it's not the same WinJS because of the differences between the platforms, but majority of the controls and utilities are shared. Some of the controls that are shared, for example, and some of the most used controls are the list view and repeater, exist on all three platforms. But as I mentioned before, these controls on Xbox, for example, when they're used there, they are enabled for voice and Kinect. So that's the work that you don't have to do if you use these. And then when they use them on phone, they work best on that form factor. When you use them on Windows 8.1, they work best on that form factor. There's also some controls that exist on one platform and don't exist on the other one, but they can be replaced in place of the other control. For example, the hub exists on Xbox One and Windows 8.1, but does not exist on Windows Phone 8.1. In a lot of cases, however, you can use the hub on Windows Phone where you use you can use the pivot on Windows Phone where you can use the hub on Windows. And because of the similarities and the way it's used and the APIs, that code can also be shared. Xbox One has also some custom controls that make it easier for providing your applications, such as the media tile, which does not exist on other platforms. But the media tile is very similar to the item container. In fact, it is an extension of the item container. So you can take the item container, add a little bit of styling and some elements, and we can use it instead of the media tile. So there's a lot of similarities between the controls that can be replaced. So now that we've gone through the comparisons, so we can go through some of the techniques I've used to share code between applications. So of course, first of all, we need to share source files. And I'm going to go through a little example of how we did that for Khan Academy. And then picking an architecture pattern will help you organize your code in a way that maximizes shareability. Then abstracting platform-specific code will minimize the amount of code you write. Using fragmentation model components just makes it simpler to swap components or manage your code. And then always separate your styles for each platform. So a little bit more detail for sharing code. We saw today with Terry's talk where he showed a Visual Studio with 3 projects. So here we have a similar screenshot of a Windows Phone, and an Xbox application. How does this work today is, in fact, you notice that this has a Windows 8 for the Xbox application. The reason why is because Xbox One development currently only works on Visual Studio 2012. However, when you create a new project for Xbox One, you also get a project for Windows 8 that shares the exact same files as your Xbox One project. In fact, you can run this Windows 8 application on your computer, and it will look exactly like your Xbox One application will look on Xbox. And that shows just how close these platforms are and how much code you can share. So this allows you to write your code on Windows and then deploy it on Xbox. And it also allows you to share your code between Windows Phone, and Xbox at the same solution. And then the way you do this, you use the new universal project, and you can add a new project to this solution. And there's some work required to add the shared project, but it's not bad at all. And then you put all your shared code in your shared project and the platform-specific code in your specific project. And that allows you to maximize, just organize your code a lot easier. And of course, don't try to share everything. I've learned that the hard way. Sharing everything just makes your code a lot more complicated than it needs to be. So if you have platform-specific code that's not going to be used on any other platform, just separate it from your shared code. Keep your default files separate. have your default.html and the default.js, default.css separate. For example, in default.html, it's where you include a lot of the source, JavaScript source that you have, and you don't always want to include the same files. And your JavaScript, default.javascript is when you instantiate the application, and there's some APIs that they can be also instantiated there that don't exist on the other platforms. Just makes it simpler to separate. And of course, your global styles should be specific for each platform. And then, of course, platform-specific files you shouldn't try to share. So let's look at a little project right now. Switch to my laptop that has this shared solution. See already? Oh, there it is. Sorry about that. So here I have a solution that has a Windows, with this, a Windows Phone, and an Xbox project. And then we also have the share project. Now I mentioned that this is a Windows 8 application that shares the same source code as an Xbox application. And in fact, I have Visual Studio 2012 open here, and I can show you the same. Show you that this has the Xbox project on top, and then the same Windows 8 project I've shared in my Visual Studio 2012 project on the bottom. So this is sharing the exact same files as the Xbox project. In fact, I can run this on my machine as a Windows 8 application, and then I can also run it on the Xbox One application as well. And here, I've separated some of the code in my shared project. For example, I've put all my localization strings in the shared project because those are easily to share. I've added some shared.css or CSS that can be shared across all platforms, some JavaScript files that can be shared. I'll go into some of these. Added my pages, and of course you can't share everything, but the stuff you can share you can actually put in here. So it's just very easy to have all your shared code in one place instead of having to just link files across projects and having to manage which files you've linked and which ones you haven't, and just have them on one central location. And this is possible with the new update to Visual Studio 2013 that we announced this morning. Now, once we have our project set up and we have our sharing set up, I usually go through and use MVVM for my architecture pattern. You don't have to. There are a lot of architecture patterns you can use, but architecture patterns help you organize your code in a way that you can maximize sharing between platforms. So for example, in model view model, the model handles all the data. The view model organizes how the data is shown in the view. So in most cases, in almost all cases, this code is identical on all platforms. So you can share this code, so you can separate this code. And the view is the one that handles the UI, and that's different on most platforms, and that is what goes into each specific project. You can actually share the view in a lot of cases too, and then with using some other techniques, you can separate the specific code into projects. And actually, MVVM uses binding and templates to do a lot of the work, and that just simplifies your code. There's some work required ahead of time to get everything set up, but once you have everything set up, you minimize the amount of code you write, and the amount of code you share is maximized. And then I mentioned this earlier in my session that Win.js is shared on all applications. However, a lot of the same controls that exist on all platforms live in different namespaces, or some of the controls that exist on one platform don't exist on another platform. For example, the hub exists on Xbox and Windows, does not exist on phone. But what we can do, we can abstract this in a way that we can use one namespace to refer to each control, depending on what platform we're on. So what I've done here, I have one HTML that I use this share.ui namespace that I've created, that depending if this runs on Xbox, we'll choose the Xbox.js or the Windows library for JavaScript hub control. If it runs on Windows, we could choose the Win.js hub control. If it runs on phone, it will choose the pivot control. And then, of course, the hub sections are also set up so they refer to the correct control as well. And then here you notice also we have I have a data when control, control.section1, control.section2, which leads me into my next pattern, which is using fragments and modular components. So using fragments makes it easy to manage your code and only focus on one area of the application. And actually, if you need to write different views for each platform, you can write them in fragments and then share the rest of the shareable code. So for example, controls.section1 can be a control, it can be a different control on each platform that gets rendered into each section, but I can still keep my sections. And of course, each component should have its own view and view model, and just makes it easier to share the view model across platforms and then have a different view for each platform. So I'm going to do a little demo on a little application for using all these different tactics. So here I have the same project I just showed you. Can everyone read this in the back? No? Yes? No? Let's increase the font real quick. Is that better? Thank you. So here's the same project that I have. So I'm going to add a little hub section. I'm not going to type it. I'm just going to copy real quick. So here I have a little hub, and here I'm using the win.js.ui.hub control. And then I have some few hub sections, call them spring, summer, fall, winter. Thought that was interesting at the time, not so much right now, but that's okay. So if I run this on Windows, so I'm going to set my starter project as Windows. And then we can see the hub control basically just appears with different sections. But of course, if I run this project in, for example, Windows Phone, and I have my phone here. So that's my phone, and the app should be deploying right now. Ignore any of the content or images or whatever you see there. There it goes. However, because we're using the hub control on phone, it doesn't exist there, so it basically just, it doesn't look right. And then let me show you how the deployment on Xbox works. So what I have for this project I already showed you, I have the Visual Studio 2012 project. And I can actually, because this is sharing the same code as my 2013 project, all I have to do is just use this to deploy the application. So I already have my Xbox set up. Switch real quick to the application. My controller died. Oops. This is the final result. Ignore this. You did not see that. Again, it looks the same. So what I'm going to do, I've already done this, is I've included in my project this shared JavaScript file. Oh, excuse me. You can't see that? What, really? Anyway, so I have my shared.js file, which is basically shared on all three platforms in my shared project. And here's I've defined different controls that can be shared across all three platforms that live on different namespaces. So you can see we have the back button, we have the hub, and the item container, and some other controls. And so I show you this code in my slide, and this is basically expose that as a shared.ui namespace. So if I just go here in my hub control and just change everything that's WinJS to shared, I'm going to change that one. I'm going to change that one. Change that one. Let's run it on the phone real quick. I'm going to try to avoid the phone as much as possible, and because of time, just want to show you real quick what it looks like. So here we have it showing as a hub, or as a pivot, excuse me. And then if we run the same project on our Xbox, we'll also get the hub experience there as well. There it is. It's just a very simple way to have a centralized location to share your code in one page. Now, I was talking about using fragments and modular components to separate the view into different little smaller components that you can manage easily. So what I've done here is I already showed you that application by mistake, but I have the same application here, but I've added more sections to it. So what I've done is if I open the same file, hub.html, you notice here I have this data win control, a control that I've created, that it lives within my folder, but I can show you what it looks like. Basically, it renders some other view that I've created, and I can have different views for each section. But if I open up my section control.js, you'll see that this actually refers to HTML hub section control.html, which does not live in my shared project. It actually lives on each one of my specific projects. So if I go to my Windows project, in my HTML folder, I have a hub.section control. And this is actually another page that has a view which is based on the WinJS.ui.flip view. The Xbox project, if I open that, the HTML, this is a different control. This is actually based on a repeater. So I'm using different views for each one of my sections for each platform, but I'm still sharing partially some of the code, and I'm still able to manage it. And then one thing you notice in my section control, I'm also using a view model to bind all my data. So I have one view model, a section view model, and I'm using an observable mixin to make it observable and make all the properties observable. So by using binding, if I go into each one of my different HTML views for each one of my platforms, you'll see if I can simply just bind each part of the application. Let me zoom in. I can bind each part of my view model, the same view model that's being shared across platform to a different view for each platform. Same thing here for the flip view. I'm binding an item data source, and for Xbox, I'm binding the item data source to the repeater. So if we run this project on Windows, so we have the flip view for each section. And uses touch, and it's very natural on Windows. And it's just a UI that's made to run on Windows. And when we run the same code on Xbox, which again, I'm going to Visual Studio on 12 just to run the application. I'm writing all my code in Visual Studio 2013. Let me switch to the Xbox. We have the application in a repeater that is more appropriate to the Xbox and uses the Xbox user experience with using the ellipsis button for more and going through each one of the sections. So we're still sharing the majority of our code, but our applications are made to work right for each platform. And then, of course, I've separated some of the code for Xbox and Windows in my projects. You can still write specific code in your share code. So if I open up hub.js, which is my main page. On Xbox, for example, because you're using controller, for example, you have to set your focus when you first load your application. So make sure that your focus is on the first element you want. So here I have this little utility that I've created in my shared JS file. This basically just checks if I'm running on Xbox. So this is a way to basically separate your code in a way that allows you to write this platform-specific code in your shared project. So I'm just doing that on Xbox. I'm running on Xbox. It's just a way to minimize amount of files that you have, so you can do it all on the same file. And then finally, probably the most important thing that I've learned while writing these applications is always don't ever try to combine your styles or your views. Doing that will cause you to a lot of headache. You'll change one style on one project. That will change the style on another project. It doesn't look on the other project. It will change the style on another project. So you always have to you always want to separate the style of your project. It's just going to make it a lot easier to manage your code later on. And also when you write your applications, it's a lot faster. So the way I've done that is I've actually using a relative path to a CSS file, for example, here, hub.css. So I have two of them. I have hub.css, which lives in my shared project, and then absolute path to CSS hub.css. And depending on which platform I'm on, each project has their own hub.css that gets applied to that page. So you can easily write the same HTML code and then still separate the CSS for each project without having to write different HTML. So if you look at my project here, you'll notice each one of my projects has a different CSS for each part. So I have a hub.css for the hub page, and then I have hub.sectioncontrol.css. Let me open that up. For each one of the sections. So this allows me to separate that code into more modular components and also separate the style for each component. And then we have the same thing for Windows Phone and Xbox as well. And if you open up the CSS file, they're different, and they refer to in the style of the application depending on which platform they're on. So moving on to Go native. So we're going to just to touch up a bit on C++. It is available on all three platforms in the form of a Windows runtime component. It allows you to use existing libraries with decades of community experience out there. A code that you've already written, code that's been tested by the community, and just makes it easy to share it across all three platforms since all platforms support it. Also, if you have any resource-intensive or high-performance tasks, you can always use C++ for those as well. You can always use popular libraries like OpenCV, the standard library, Boost, if you've already been used to those, so you don't have to go away from those. So I've created a little application that uses the Media Foundation on Windows 8 to share a C++ code that essentially creates a grayscale effect on a video. So I'll show you what that looks like. So here I have my application for Windows and Windows Phone. And this has this grayscale transform project, which is also a shared C++ project, which has the shared section here. I'm sharing C++ files in a shared project, and then have specific project for each platform. But notice there's no code here in each one of these. They're basically just projects that allow me to compile the code for the appropriate platform. So if I run this on Windows, so I can select the Windows project, you notice first in the references, I have a reference to the Grayscale project, which is the Windows version of the Grayscale project. Excuse me. Should have named that better. And then on the Windows Phone, I have a reference to the Windows Phone version of the C++ Grayscale project. Now, this Grayscale project is something that I downloaded off the Windows 8 samples. You can get it right there. I didn't have to do any kind of changes. It just worked on all three platforms. And so if I just run it on Windows, excuse the UI. This is a video I took with a little GoPro camera in my office. I couldn't think of anything. So I can change the effect, and this will basically change it to grayscale. It's just a very simple effect. Uses C++ to run through, to inject into the media pipeline, and just make the video grayscale. So I can do the same thing on Windows Phone. There it is in grayscale. And the same thing works in Xbox. So I'm showing the exact same code, except I have it here. So it's the exact same code. It's linked in my C++ project with link files to the same project that is in my other solution. And I can run this in my Xbox. Of course, it has to build first. And here we have the same video. And now it's in Grayscale. So it's using the exact same code, same C++ code. You can move it from one platform to the other. No changes for each one. It's just a separate project file to compile it for the right platform. And then credits to my coworker for the pictures in the other app that I showed you. It's in the wrong place. But he let me use his pictures on his Flickr account. If you like those pictures, just visit his Flickr account. He made me put his stuff on there. So finally, I want to go through a little bit over the Khan Academy application that we saw this morning, see some of the how the application was written, show how the same patterns or same things I showed you here today are applied to that application. So here's the project for the Khan Academy application. You notice we have the same pattern. We have the Windows Phone, and Xbox project, as well as the share project. You notice that we have a lot of the same code that is shared across all three platforms. So if you go into the home page, for example, here you notice that we have the same shared.ui.hub experience, same control that we have in the other project that I showed you. And this has share.ui.hub section. And this is running, of course, on all three platforms, and it's using a user control. And this user control is different depending on which platform I'm using. So it's just like I showed you before. It is used to show the user information. It shows different information depending on which platform you're on, and it lives in a different project. So depending on what project I'm running this on, it will grab the right control. And then, of course, it's not only just one section. I'm loading a lot of the sections dynamically because of the way the data is being loaded into the application. And for example, so I can do that in my home.js, I basically create a shared.ui.hub section, which again, depending on what platform I'm on, will create the correct control and add it to the shared hub. And this will look exactly the same. And it will look appropriate for each platform since it's styled for each platform appropriately. One of the greatest examples for using a architecture pattern is in the search page. So if you visit the search.js page, you'll see we have this view model that has all the controls, commands for searching and filtering the data and exposing all the data to the view. And this is shared 100% across all platforms. And if you look at the search.html, we'll notice we have this CSS/search CSS that's basically just styles for which platform we're on. So if I run this application, so I have the Windows application. So here, that's the user control that I mentioned before, which shows the different users, what the user is logged in. I'm still logged in as Terry, forgot to log out. But I was mentioning search. Here we have the native search experience for Windows. And it takes me to the search page, which is the same search page that I showed you. But if I show you the same page on, for example, Windows Phone, you notice we don't have the same search box control as we have on Windows, but we can use it as an input box and still have a similar experience as we have on Windows. We'll pull up data. And then finally on the Xbox. That's not good. We have the native search experience that we have on the Xbox by using the same code. So in summary, the Xbox One is built on the same Windows core that Windows and Windows Phone are built on. So they share the same Windows runtime. So you can use the same APIs and a lot of the same features. Take advantage of the Windows platform today, the Windows and Windows 8 Phone platform today, to build Windows Phone Store apps that will be able to move to Xbox One. We also have a room at Expert 101. If you have any questions, you can come there and talk to the Xbox app team. They will be here, and they're here, I believe, all week. Oh, and then, of course, fill out the session survey. There's going to be, actually, after this slide, sorry, I missed that. I'll leave this on later on, so you can scan this and then give me the feedback that I need horribly. And then, of course, we have a developer partner program for partners that offer middleware and services for applications, and they're encouraged to join this platform. Just email xboxdpp@microsoft.com for more information. And so just scan the QR code. Make sure you give me feedback. It's how I learn and how I improve eventually. And thank you. I guess we'll go into questions now. Yes. If one, you can go to the mic so they can hear you on the video as well.
How is this different than dividing your existing app into a common library and then compiling them differently for each platform?
It's not. It's very similar to the way you do it. You're talking about how you do it in .NET for C#? Is that your question? Yeah, so this is This is a new Universal project that was just announced this morning. I'm not the expert on the Universal project, but it is, the way it works is pulls in the right files when it's compiling the project, so that way you have one project when it's deployed to the application. Is that your question? Yeah. Any other questions?
Are we always going to need to have 2 different IDEs on our desktop to support the Xbox?
We don't have anything to announce today, but the goal is to make this experience converge with the Windows Phone platforms. So we're working very hard to make sure that in the future, all the platforms are converged. So the platforms are converging. They're converging more and more. But eventually, we're hoping that they will be a lot simpler for developers to develop on the applications. Yes?
Are there going to be new UI controls built in for which you don't need to change the view for each of the platforms separately?
Not that I know of. No plans right now. Then not the right person to answer that. Yes?
How are you physically deploying to the Xbox?
So this is, I'm using just remote deploy. It's very similar how you do remote deploy on Windows 8 today. You just use the IP of the console, which exposes that feature once you have an Xbox, which is developer enabled.
We can't get those.
Nothing to announce today. Of course, we want to get your ideas and everything on the platform, and we're very excited for that, but we have nothing to announce, and please stay tuned for later on. Yes?
Can we build games across Xbox One and Windows, or is that something we need to be...
So there's actually a session on that topic. I'm not the game expert, but let me pull up the session list. So by Frank Savage on Friday, there's the Understanding the Xbox One game platform built on Windows, and I imagine he will go into more details how to share code between Windows and Windows Phone as well. I was expecting a lot more questions. Go ahead.
You know the first slide you showed, the GUI and video?
Yes.
Is any of that available in IE now, so that you could build stuff, on a server that would run like this? Or is that purely for the developer, right?
Are you talking about gesture or voice?
For voice. So for instance, the tag that you had, you use now in IE 11?
Not right now. That's Xbox specific only at this point. Yes.
Can you be more specific about what the limitations are around the Xbox regarding Visual Studio 2012 versus 2013? So just you can only compile and deploy and debug and anything. Is all 2012 right now? Is there a timeline for that changing?
So we don't have any timeline right now. We're working to converge the platforms. The platform was built on top of Windows 8 and IE 10, so it's very close to, of course, Windows 8.1. Was built to run in Visual Studio 2012. So that is what we have right now. Yeah. Yes, go ahead. No, please.
I don't want to keep asking questions.
No, please do.
I might not be able to answer, but for instance, the one where you're putting it into the Xbox environment, how will that one work? Will there be a store, or will there be...
So we have a store right now where we have all the applications in the store where a user can go download them. We don't have exact details right now, but there will be a certification process, of course, like we have for Windows Store and Windows Phone right now, where you have to go through certification to make sure the application is ready to go to the store, and then we'll live just like how the store and games live in Xbox right now. Yes?
So how do you expose the C++ administrative? Was each platform rebuilding the C++? Interfaces?
Sorry?
The C++. How
Yeah.
were you,
So can you, please use the microphone.
how were you exposing the C++ interface?
So we're using the Windows runtime components, which are used exactly the same way in Windows and Windows Phone, or Windows Phone 8.1 right now. So it's the exact same way we've been doing it for Windows 8 and Windows 8.1 until this point for the past years. Yes?
Is there an overhead of using any one particular language?
Excuse me?
Is there an overhead of using any one language?
Currently, Xbox One supports JavaScript and HTML5. We don't have anything to announce about any other languages being supported at this time. Is that your question?
No, the question was, is there, like, if I choose JS or WinJS over C++,
Mm-hmm.
is there a performance overhead?
It will be the same way if you do it on Windows 8 or Windows Phone. Of course. I mean, you get access to the same features, to the same APIs through each platform. You just limit it to what kind of, what libraries you're using, of course. And honestly, I'm not the right person to answer that. But come back after the session, and I'll get you in contact with the right people. Okay? Yes, go ahead.
Building for Connect going to be identical across Windows and across Xbox?
So we have a session with Chris White that goes into development for the Kinect for Windows. He will go into a lot more detail on how that works right now. Again, the SDK will be released in June, and we'll have more details as that we get closer to that. So please go visit his session. Cool. Well, thank you, guys. If you have any questions, I'll be around, so please come by, and then we can chat.